Hello dear friends, welcome to this video. In this video we'll be discussing this question number 8. Let me just read it once. So my A is nothing but the diagonal matrix 1, 2, minus 1 as the diagonal entries it will have. My B is nothing but this matrix which they have given. C is nothing but this and D is nothing but this. They have given 4 options like this. Just read it once and try to think about it. They have given that BCD is similar to A, only D is similar to A, none of BCD is similar to A and A is similar to D. First of all, I will just see this. These two options are actually some kind of similarity in them. Let me just see this option first of all. B, C and D are similar to A. Okay, we know that if the two matrices are similar, then they have the same trace and have the same determinant also, right? Suppose my A and B are similar, then they must have the same trace. What is trace for this matrix? My A will look like this. It is 1, 2, minus 1 and the rest of the entries are 0. So what is trace of this? Trace is nothing but 2. Over here, my trace of B is nothing but 6. So my B is not similar to A, correct? So this option cannot be right. Also, if you see this, over here, my trace of C is also 0, correct? So C is also not similar to A, you can think like that. So option A is not right. Also, if you B is not right or not, let's just check about option B. Only D is similar to A. Let me just think about it. D, this matrix, and over here is also 3 cross 3 matrices. Okay, so 3 cross 3 matrices are same if and only if they have the same characteristic and minimal polynomial, both must be same. Okay, but actually we won't need that result also. Let me just see this matrix D and find out the characteristic polynomial. I know if they are similar, they must have the same eigenvalues, correct? Let me just find out the eigenvalues for this, or just check is it having an eigenvalue as this or not. Okay, so since we know that for a diagonal matrix or a triangular matrix, the eigenvalues are nothing but the diagonal entries, right? Over here for matrix A, the eigenvalues are 1, 2, minus 1. For any triangular matrix, if I have given, then eigenvalue must be the diagonal entries. Let me just find out the eigenvalues for this. For that, I will need the characteristic polynomial for D. I am using the variable as lambda. So it is lambda cube minus trace of D times lambda square plus my, I will write D11, D11, D22 plus D33. Okay, why I am writing, I don't know this notation. So it is nothing but determinant of D. This means what? These are nothing but minors, right? Okay. So this is, what is the trace of this matrix? Trace is nothing but 2. So it is same as lambda cube minus 2 times lambda square. What is D11? D11 is nothing but the determinant of this, correct? D11 after deleting first row and first column, determinant of this, that is nothing but 0, correct? Yes, so it is 0 plus what will be the determinant for 2 2, yani ki we have to delete second row and second column. So if I delete this part and this part, what I will get, the determinant is again 0, so it is 0. Okay, so after that D33, so I delete this, so I will get this, right? Third row and third column, I'll get this. So it is 0 minus 1, so it is minus 1 times lambda. Minus determinant of this matrix. Let me just find out the determinant. It is nothing but minus 1 times the determinant. So I will just rub. Okay, so minus 1 means I have to delete this and this. Determinant of 1 0 0 2, so it is same as minus 2, correct? So it is same as minus 2. Okay, so what we got is this. Let me just check for it. This is nothing but same as lambda cube minus 2 lambda square minus lambda plus 2. Okay, so let me just check one is an eigen value for this matrix D or not. So if it is an eigenvalue, it should satisfy this equation. So my PD of 1 is nothing but what? It is 1 minus 2 minus 1 plus 2. So it is coming out to be 0. So 1 is nothing but an eigenvalue. Let me just check for the minus 1. Minus 1. So it is minus 1 minus 2 plus 1 plus 2. Correct? On the place of lambda I am just putting it. So this is the thing but giving. Answer is 0. Let me just check for the 2 also. So it is 2. So it is 2 cube is 8 minus again it is 2 times 2 square, that is 2 times 4, it is again 8 minus 2 plus 2, so it is also 0. So I found that 1 minus 1 and 2 are eigenvalues of D, correct? So that means what? My D is nothing but diagonal matrix, diagonalizable matrix, correct? It is nothing but a diagonalizable matrix. Since it has a distinct eigenvalues, correct? Since it has a distinct distinct eigenvalue, it will have 3 distinct eigenvectors also. Hence D is diagonalizable and it will be similar to A. So but the question is asking you for the 2 similar options, means the solutions giving you 2 similar answers. Only D are similar to A and A is similar to D. So both are true according to me. So there is some printing mistake, but this is definitely not right. So B and D both could be ticked. Okay, so thank you so much guys for watching this video. अगर आपको अच्छा लगता है तो प्लीज़ लाइक कीजिए, शेयर कीजिए अपने फ्रेंड्स के साथ और चैनल को सब्सक्राइब कीजिए. ओके, बाय बाय.